Today we're going to be talking about a paper called Composer, Creative and Controllable Image Synthesis with Composable Conditions. Now essentially what the authors of this paper did is they leveraged this idea of compositionality, meaning the ability to decompose an image into representative factors, so that's what they're saying here, to create a model called Composer, which according to them supports a bunch of levels of conditions to use when generating images. You can create images from a limited set of sub-representations. And what these representations are, they can be things like the shape, semantics, sketch, masking, style, content, intensity, and the color palette that makes up an image. So you can use these subsets and you can rearrange them, recombine them to create new original images. Now, the way they did this is by devising a joint training strategy that's composed of two phases. Your decomposition phase and you have your composition phase. Now, in the decomposition phase, they broke down the images into a bunch of individual representations using computer vision algorithms and pre-trained models. Pre-trained models like OpenAI's Clip using vision transformers, for example. And in the composition phase, they optimized the models to reconstruct these images from their representation subsets. So on the one hand, you have a decomposition phase where you break down an image into like a set of 8 sub-aspects of that image. And then on the composition phase, you train the model to reconstruct an original image from those subsets that you created. Now, there's a lot of interesting things about this paper, but I think one of the most striking things is the flexibility of the customization that you get with the model like this. Now, in this image here, that becomes super clear because, for example, they're doing a bunch of variations on top of an image, but they're maintaining the shape because now, since you can control shape as a composable element of the image, you can keep it fixed and then change other stuff about the image. This kind of flexibility kind of gives the model a lot of generalization capabilities. That's why they call it compositional generative models, which is a reference to this ability of composing and generating new images by rearranging composable elements. So that's one of the first very striking and interesting things about this paper. Okay, so getting into the two training phases that are described in the paper. In the decomposition phase, you decompose an image into decoupled representations that assume various aspects, that capture aspects of an image. Right, so you start with an image, you decouple that image into a bunch of representations, and what these representations are, they can be the caption that describes what's inside of an image. They can be the semantics or style, which in this case is a more general concept and refers to the idea of, for example, in the case of this painting, when you keep the semantics fixed, you see that there are elements of the image, like there's a girl with a given background, with a certain style for the painting, and all those things are maintained fixed. So they are a bit loose, and the definitions of these composable elements is a bit subjective, but you can see empirically that those things are usable and that they make sense. Even though there's you can discuss, how is it that they're defining these things, and you can maybe, have some discussion about whether or not that makes sense. But it's striking to see how, despite the subjectivity of these definitions, the actual outputs look quite striking, quite interesting. Now, for the composition phase, they train the model to recompose images from these sets of representations. And the set of representations are the ones that we just discussed, right? And for this phase, they had to have the ability to condition the generation of images based off these subsets. They came up with these two conditioning strategies. You have a global conditioning strategy and a localized conditioning strategy. The way I looked at this is they needed the ability to do global conditioning for aspects of an image that kind of touch upon the entire context under which an image is created. And then for the local conditioning part, local conditioning was focused on what they call localized representations. So these being things like sketches, segmentation masks, depth maps, intensity images, masked images, and then they go into these specifics. And then this joint strategy, the joint training strategy that they use, allow them to join these two conditioning approaches. There's a bunch of interesting outputs from this paper, and I think that when we look at, for example, image reconfiguration, now one of the things that they argue for the flexibility and the customization capabilities of this of the model is the fact that you can do really cool and interesting image manipulation techniques. And these are things like image variations, like you're seeing here, a variation on the image on the left shown right here. And you can do a bunch of variations according to different composable elements that you might care about. For example, here we're looking at, I think it's, they're doing based off masks and sketches, and they can create these representations that you're seeing here. And the same thing here, but now they're adding color palette, which is here on the right. And, you know, they show a bunch of examples of how this thing can be created, and it's quite interesting. Besides image variations, you can do image interpolations. Now, for image interpolations, you have this really cool capability. Now, if you look here on the left, you have the original image, and then you have a target image, and you want to interpolate between these two images. And by using the composer model, you can have, some, normal interpolation like you're seeing on top. We're just doing an interpolation from the one on the left to the one on the right. However, if you look at the third row, this is one of the coolest interpolations that I saw. This is keeping the shape encountered in the image fixed, and the interpolation is occurring in all the other aspects of the image, but the shape is fixed. So it's really cool, because then you see how by maintaining the shape fixed, the interpolation is restricted to the representations that are allowed. So the composer allows you a lot of flexibility when you're playing around with image interpolation, and I thought this was a really cool result. Besides that, the model has quite striking image reconfiguration capabilities. For example, you can look at this example here where they remove the arms of the Vitruvian Man from Leonardo da Vinci, which I thought was a really cool example. Besides this example, I also like this one where they have a helmet with glasses, and the composer model allows you to remove the glasses. I mean, I've seen this before, but I think that the fact that they're doing this by being able to access let's say a composable element and then say, I don't want to have that in my image anymore. I thought this was really cool. I mean, I've seen it before with images like Guns Dissect from MIT, but nevertheless, this model seems to have really interesting capabilities. Now, besides those, the model also has a capability that they call editable region, which I thought was quite cool. So essentially, you can select a region in an image and then ask for variations of that image, but only within that region that you selected in the beginning. And you can see the results here on the case of this pie or cake or whatever this thing is on the first line. And you can see also the interpolations within the face of the portrait here on the left. And then by interpolating between the face of this, the painting, all the way up to the face of the painting on the right, you see how interesting this ability to edit, to set a specific region of the painting as editable is actually quite interesting and showcases some really cool results. Same thing for text condition generation within the editable region. You can say something like the painting of a cat. However, you restrict the space where you can actually have this text condition being applied. And in essence, what that means is that you can have something like this, which is the cat, but the ears, since the ears were not in the editable region, they stay as the ears of the bunny in the beginning. So it's actually quite cool to see the outputs of the model by using this approach. And then they show with colorization and reconfiguration where you can do similar things. Now, besides those capabilities, the authors argued that this approach kind of does a reformulation of traditional image generation tasks, because you can have a model like Composer being directly applied to all the tasks that are usually distributed across a bunch of tasks. We used to think a few years back in terms of, you have a neural style transfer model and then an image translation model, a post transfer model. And now Composer, according to the authors, can do all of these. And you can have one model doing all of these things, which they say argue for the flexibility, the customization capabilities of the model, and also for its generalization capabilities. Which, it's quite interesting how you can use just one model and you can do palette-based colorization, you can do these awesome color interpolations, you can do style interpolation, you can do style transfer, you can do image translation, you can do post-transfer. I don't know if I saw here some results for the quality of each of these tasks, but at least the empirical results that they share in the paper are quite interesting. And finally, one of the coolest figures in the paper is this paper showing the compositional image generation. So the results produced by Composer, where you see the power of these composable elements when they're joined together. So here on the bottom, you see the subset representations that were used to create the image that you see on top. And you see that if you set a certain segmentation with a certain sketch, with a certain color palette, you can get these variations that you see on top. And then they do a bunch of variations depending on a different subset of representations, and the outputs that you get are really, really striking and really, really cool. I especially liked the text conditional generation outputs, because you can just say something like a fluffy baby sloth with a knitted hat, and then you can set the color palette, for example, like they're doing here, and you can get the output that you're seeing on top, which is really cool. The photo of a dog wearing glasses. From what I got from these results is that you can get high quality image generation. However, you have much more controllability over how those images are generated, which is really interesting. Finally, they conclude showing how this decomposition and composition paradigm demonstrates that when conditions are composable, the control space of generative models can be vastly expanded. So rather than having independent conditions, if you have composable conditions, generative models gain this superpower of joining and combining different elements to create new images. And you get all these abilities that we talked about, like editable region and reconfiguration. And essentially, I thought this paper was really cool, really interesting. I think they're a bit subjective on their definition of the sub-representations. I think that the reason why they used shape, semantics, sketch, masking, I think those sub-representations were chosen based off how easy it would be to create those representations given the availability of pre-trained models and algorithms that would allow them to have these aspects of the image deconstructed. However, the way they use these algorithms and these pre-trained models to create this kind of like environment where you have these different ingredients that you can use in different recipes to create different and creative original images is just, for me, it was mind-blowing to see. And these image synthesis capabilities with these controllable aspects is something that I think is going to be paramount when we start looking at the interaction of large language models and image generation models, as we see multimodal models starting to take over. And I want to cover a few papers on this topic in the future. But overall, this paper was really interesting. I really like it. And if you like this video, don't forget to like and subscribe, and see you next time. Cheers.